and let's start our webinar today. So, first of all, I would like to welcome our today's attendees for the webinar. Thank you for taking out the time from your busy schedule to learn more about today's topic, that is enterprise level engineering change management that can be driven through PLM system. So let me quickly introduce myself, my colleague, the organization, and then we'll deep dive into today's webinar session. My name is Mayur Gundale, and I'm very excited to introduce you to today's topic that is crucial for maintaining efficiency, quality, and competitiveness in today's fast-paced engineering environments. So let me quickly start my video so that I can be visible to you. And I'll request my colleague, Mr. Ashil Shah, to switch on his video for a brief amount of time so that we can introduce ourselves. Yeah, that's it. So when we talk about engineering change management, I mean, what does come to our minds? I mean, it's just more than a process, right? We all know that, because it's vital strategy that ensures that the product changes which are implemented needs to be done very smoothly, with minimal disruption and with full traceability. So an effective engineering change management can help any organization manage and track changes to their products and processes so that you can ensure that every modification that is being done can be thoroughly reviewed, approved, and documented. So today what we'll do is that we'll explore the key aspects of an enterprise level engineering change management and how it supports the entire product lifecycle. We'll discuss about the importance of having a structured approach to handle changes, the challenges companies face in managing changes without a robust system, and the benefits of implementing an enterprise level engineering change management using a PLM system. So we, Softcell Technology, we deal into ETC's world-class products such as Windchill PLM, CAD software, ThingWorx IoT, and Euphoria augmented reality solution. We specialize into this advanced engineering solutions, including, as I mentioned, about PTC's renowned Windchill PLM system. So our motive is to explain to you today's topic through how engineering change management can be driven using Windchill PLM system. But to deep dive into today's topic and all the technical aspects related to it, I will request my colleague, Mr. Ashil Shah, to show you a practical demonstration. So Ashil is our technical consultant. He's an ex-PTC himself, and he will walk you through the entire presentation of Windchill PLM and how it can be leveraged for effective engineering change management. He has extensive experience into this field of PLM technology, and he will provide you with a detailed presentation followed by a demo. To quickly explain to you about Softcell Technology, our organization. So Softcell is basically a system integration organization. We have more than 30 years of experience in the domestic market, having 3,000 customers across the entire country. So we have 6 offices at pan-India level, Delhi, Mumbai, Chennai, Hyderabad, Bangalore, and Pune. With more than 750 people, we have been able to serve all our customers. And we have a revenue of close to 900 crores as of now, which has been helped by all our customers to reach us to this level. Now, as far as PLM solutions are concerned, what we basically do is we deal into providing various PLM offerings, right from providing consulting services where we actually do PLM audit for our customers, where we examine their existing systems and the processes. So we discuss all the possible potential improvement that can be done, and we, according to that, provide the PLM roadmap for implementation, which are tailored to our customers' business objectives. We do complete new implementation. At times, customers who have already implemented Windchill, but they have not got the benefits, so we do the re-implementation for those kind of customers. We provide PLM upgrade and enhancement services so that we provide the perfect fit of integration between multiple systems such as ERP, CAD, or other business management applications. Along with this, we also provide PLM training and adoption services, and through our application management service, we help our customers in post-implementation support as well. So this is quickly about soft sell, and in PLM business, what we do, how we help our customers. But coming back to our today's topic, I'll request my colleague Ashil to take over this presentation and help all of you to understand more about how engine change management at an enterprise level can help in improving your product development process, which can be driven through a Windchill PLM system. So Ashil, I request you to please come forward and take over to this presentation.
Sure, thanks. I hope I'm audible.
Okay.
So what I'm going to do is I'll just I'll stop sharing the video and just for saving the bandwidth, and I'll go ahead and I'll share the screen. Just let me know once you're able to see my screen. Is my screen visible? Mayur, is my screen visible?
Yes, now it's visible.
Okay, perfect. Okay, so today's topic is, the webinar is going to be about the engineering change management using Windchill. We'll see how the process is, how it helps you, in decreasing the chaos of change management that, and how it keeps the accountability, how it gives you the automated flow, and so on and so forth. So, we'll start with, the challenges normally which is faced as on today's date without having the actual, change management scenario, or you can say the change management support that is actually present at your end, having the software. Now, even if the softwares are present, many people, they use software like, a bug tracking software, or, they will be using the homemade software and all those things. So the homegrown softwares are going to be supportive to some extent, but they will not be keeping all, each and every accountability, each and every automation, in the sense the baton passing from one person to another, going with the fast track, going with the slow, full track methodology. We'll see that today, how actually Windchill is going to be supportive, as opposed to actually having a less efficient or not having a software system in place. So without the system in place, you're going to be having a slow, inefficient change processes. Is going to be difficult in identifying, the data requiring change, because, any engineering change is not going to be as a single change. It's going to be a complete battalion of changes, because one thing is looped to another one. And then as a result of which, there will be a lack of visibility to, the change status at every corner. There will be a change within the engineering department. There has to be a simultaneous change where you're going for a manufacturing. The simultaneous change has to be visible where you're going for us, procurements and so on and so forth. So, also the system, even if the system is there, it's not going to be in sync with your ERP system. So, the updates are not going to be getting reflected in an automated manner. So as a result of which, there will be a poor document quality that is actually maintained. There will be rather negative impacts of changes. There will be you'll not be able to do a rapid change introduction to every corner, every department across the organization. There will be manual handovers, which is going to be rather inefficient. So actually, if you're going for digital transformation with regards to change, it is supposed to be having an agile change management. There should be a proper business justification. There has to be a proper review that has to be done within the engineering department. Manufacturing should be involved. They should be, fixing the processes that is, related to the engineering data. Then the suppliers will be involved, which will be actually, present for supplying the parts, or you can say raw materials, and it has to simultaneously change or sequentially change as you're actually making a change in design. So some of the roadblocks, you can say, like, the companies must directly make a plan and implement changes. The engineering should need to identify that specific change. It has to be a bomb driven change. All the relevant team members are supposed to be, involved in it. They should be notified on time. They should be actually playing their roles sequentially. It should be flexible to actually execute. So there should be visibility, there should be a proper governance, there is supposed to be a proper automation where, all the responsibility baton should be changing from one hand to another hand seamlessly. There should be a proper coordination, there has to be accuracy, and above all, there should be a traceability even after change, so as it is rest assured that complete change has taken place from end to end. So before we actually go into the change management process with Windchill, what exactly is Windchill? Now, when we see over here, the Windchill is a production proven software. It's a PLM software, which is actually a battle proven one. And it offers a complete life cycle know-how right from the concept or the ideation right up till the obsolescence of a product. Now, when we see, let me just change the cursor to the pointer for a moment. So when we are seeing, like, the Windchill is going to be having EBOM when it comes to, the PDM level, product data management level. It is highly scalable, though. You can see, like, it has got various different, combinations in its arsenal, I would say. So it has, it is really formidable where you have multiple choices that you can make and scale up the venture, but you start with the PDM. So within the product data management, you're going to be having EBOM, you're going to be having document management, then you'll be having a 3D design, multi-CAD data management, and you will be actually having a project management, a complete global development functionality you're going to be having. Like if at all you are having multiple R&Ds plants co-located, it doesn't matter to Windchill. Windchill will actually be supporting it as if you're sitting beside and you're working, because it is going to be having a baton exchange in an automated fashion. Now, once you scale up, you will be going ahead with many other things, which is you're going to be having the MBOM incorporated, SBOM incorporated, and even if you're into the PDM, product data management, you're going to be having a visualization, configuration management, of course, a change management. But when you're actually into the PDM, the change management process is going to be different. It's going to be just the design change management vis-a-vis an entire engineering change management. We'll see it step by step. So going with the change management, we'll see what are the key capabilities of Windchill when it comes to the change management. So Windchill has got the capability of following the best practices in an automated fashion, in which you are going to be having a standardized automated change management, integrated, all cross-discipline change management can be implemented, executed, and audited above it. All the integration will be there. A deviation management can be governed, or it can be initiated along with the problem reports as well. So it has got multiple capabilities, and all of them are CM2 compliant, out of the blocks, closed loop change management. But before going deep diving into the engineering change management, let us talk a little bit about the design change management. So change management overview, we'll see like what is the building blocks for controlling the data within Windchill. So Windchill has got all the objects. So Windchill looks at all the data like your CAD data, document, BOM, even the change management related objects, all of them are looked at as the object because Windchill is developed in Java. So it has actually evolved after being developing. It has actually come to the advanced version, of Java servlets and all are utilized. But still, the base is like it is gonna be looking at all the artifacts as the objects. It's going to be having a property and it is going to be having a function. So we'll see like, how Windchill basically keeps the data. So when it comes to the product, Windchill will be keeping it in the product context where, the security is going to be too high where the person working on one product until it has been he's been involved into another product, he will not even be able to access another product. So that's stringent it is. Library is like where you have all the data which is a general data, nuts, bolts, fittings and all those things like a standard parts. The standard documents could be present out over there. The SOPs can be kept over there and all those things can be kept into the library context. And then of course it has got the project context where you can actually create a project. You can have a complete milestone summary of activities, you can have the deadlines over it, estimated start date, estimated finish date. You can call in the people as resources to execute the data brought in from the product context to mature that specific data, and you can actually place it into the product context. Now, this particular complete project can be even viewed within the Gantt chart. So a complete project management is there within Windchill, library management and the product management is there. All these things are actually having a role-based access. As I told you, when the person is actually been brought into the team of the product, then and only then he will be able to view that this particular product exists. But how will he be brought into the team? His username will be added to the roles within Windchill. Like, there is a product manager and then there is an engineer who has to be brought in who will be designing a product. A product manager will be adding his username under the user role called as design engineer. Similarly for manufacturing, similarly for the quality, similarly for the review, similarly for the approval management and so on and so forth. Apart from that, Windchill has got the life cycle states. Life cycle state is nothing like, but then, the actual part will be having certain life cycle like from the in work, in the sense in the ideation state, it is going to go into the design state, then it will be released for manufacturing. If it is going into the obsolescence, it can go to the obsolescence stage. If it is cancelled, it will be actually the project is cancelled, it will be going into the cancelled state. So this particular way, Windchill manages the life cycle of the product, and it has got multiple advantages, permission related advantages and so on and so forth when it actually has got a life cycle related governance. So once it is released, then only it will go for the manufacturing. Before it is not released, it is in the in-work state or in the prototyping state, a manufacturing guy will not be able to access the data. Okay, so coming on to the design change management. So when it is in the PDM state, it's going to be a design change management where you're going to be having a design change incorporated, where even if it comes as a change notice, our designer will be taking it within the design change management, making modifications It will go through the approval management. It will be actually going for a review, in the sense a person creating data, maybe a mechanical data, maybe electromechanical, maybe software. It has been put or pushed into Windchill. So when anybody pushes the data into Windchill, it is called as check-in. And if he takes out for modification, it's called as a checkout. So when he pushes into the Windchill and creates a promotion request or a request for the approval, it actually goes to the person who can approve it. He can send him for a rework or outright reject it. Okay, so if it is going to be approved, it goes into the release. If he rejects it completely, it is going to go into the obsolescence. Now, this is actually a design change management process. And once that is done, it is actually released for manufacturing. Post-release release for manufacturing, it is going to be an overall change management, which is going to be an engineering change management. Okay. Let us see the processes in the engineering change management. Windchill uses CM2 compliant engineering change management, in which what happens is, like, there is a multiple stages in which the change management processes is governed. The problem report is created by the person who has actually found the mistake or an issue with the actual design. Similarly, if a person has got some ideas, he can create a deviation or a waiver. Then it goes to a change request. Once it goes to a change request, it gets evaluated, and then it actually formalizes completely for the execution. It actually becomes a change notice. Once it goes into the change notice, a change task is created where a person is appointed for making a change. Once a person completes his task, he will be closing his task. The person who has created change notice, he will be notified. Once he is notified, what he is going to do is, he is going to give a date for the deviation, sorry, the date for the effectivity, when this particular change has to be implemented on the production unit. Once that happens, he will be closing his task. Then the person who has created change request will be notified. He's going to check it, and then he's going to be closing his task. A person who created problem report will be notified. He's going to check, and he's going to be closing his task. Apart from the guy who is there within the design department who is going to make a modification, all of these guys who are there who will be accessing data will be accessing 3D data as a simplified representation, or we can call it as a mock-up of the actual part, which is going to be 100% replica of the 3D model. And this particular replica can also have dimensions associated, all the 3D dimensions associated with it. If the person is not able to view the dimensions present out over there, he can even analyze the data and he can view the dimensions as well. Even that is possible within this particular tool. This particular tool is called as a CreoView Express. It is meant for a non-CAD users. We'll see it in a demo in a moment. So this particular thing is normally used by the people who are actually reviewing, who are manufacturing guys, who are, the guy who are into quality, supplier, purchase, so on and so forth. So coming back to each elements present within the change management process, problem report is actually, can be created by the person who is maybe like a manufacturing guy, maybe like a quality guy, maybe like, a person who is involved in this particular project. He can create a problem report to bring on to the attention to the people that this particular part or the design has got some issue. It can result in the change request. It is not required that it should be initiating from the problem report itself. One small example is, if the person is from the management side, maybe like a CEO, a VP of the company, or maybe like, a complete design or a BU head, he will not go through the hassle of creating problem report or a change request. He wants it implemented, right? So he will be directly creating a change notice. So this problem report can be created by anybody. Multiple problem reports, deviation request can form a change request. But before forming a change request, it goes through a change admin process. We'll see that in a moment. And then it actually formalizes to become a change request. Multiple change requests can be taken into consideration to create a change notice. Once the change notice is actually created, the plan of action takes place. But prior to that, when it actually formalizes where the change request is created, there itself a decision is made whether it will be going through a full track change or a fast track change. Now, the fast track and a full track is something like, maybe if it is in a prototype, it is released, but it is a prototype where the toolings are not developed. It can go through a fast track change. If it is released for manufacturing and it is costing, it has got a higher impact, it is already on the production line, and many other people's consent is required, it will go through a full track change management. Now, once the change notice is created, it will actually give an edge, or it will be actually giving a person to plan out the implementation, how the implementation process is going to be, in which even a task, which is a change task, is actually generated, in which the instructions are given or specified, as to what are the change that has to take place, and certain times how the change can take place is also mentioned over there. So we'll see that in a moment. So the fast track is oversight, and then when the full track is there, a complete change review board is involved in it. So we'll see this in a moment, but the vision of a change management is, the parts could, change management process for changing a part or a design could vary from simplicity to the complexity. Change management process is there as to see, how simple and how robust the change management process could be. It can involve multiple discipline. You can say like a cross-functional team will be involved over here. So it can be planned out over here itself, and accordingly the change management process can be built. The impact of the change can be actually governed here itself, like there is something called as where used within Windchill. You can see as to like in how many parts are being impacted by the change. Do all the assemblies in which this particular part is, do all of them they require this particular change or not? What is the financial implications, and so on and so forth. You can also have a decision quality improved, having a complete visibility on the fingertips. So as you can see, this is a complete bill of material present out over here. This particular bill of material, each part within the bill of material will be containing multiple things like a design, like documentation, the drawing of the design, the calculations for the design, any software related to design, any test plan related to design, all of them will be getting impacted. So when you're actually making a change, you can plan things out here itself. Now, coming on to the change request process, as we have seen, there will be a need, there will be a need identified for making a change. Then the investigation will be there, which will actually see whether it has to go to a fast track or a full track change. Then there will be if it is a major change that is to be implemented or a minor change to be implemented, what are the approvals that is going to be required for that? What are the validations and verification post the change that is required? There will be a review for the change. There will be an audit on the change as well. And then it will be released for work. And then there will be a change, obviously, which is going to be a trailing change within the production side as well. So all these things are going to be taken into consideration. So a complete layout is defined initially itself. So there are various roles which is present out over here at different gates, which is present within the change management process. If the problem report is created, a change admin will be the one to judge whether the problem report is justified or not, or it is worth being implemented or not. Then there will be a change request that is created. A design team and other, CFT will be involved into it. Then the change admin will be there to see the impact of it. Once the change notice is formalized and implemented, then there will be a change admin present out over here. So each people, now it is not carved in stone. The roles and hats could differ slightly with this, but then the change roles are there. Different kind of change roles are present out over here. The change admin will analyze the problem report. Change review board will be seeing whether it is going to go through fast track or full track. Change admin will be creating a change notice and a change task based upon the change request. Change implementation, this is where the person will be appointed. The change implementation board could be a part or the panel of the team leads of a design department, various design department, where they will be involving their engineers to actually make the modification. Once the modification is done, then there will be a change admin 3 involved, where they will be checking whether whether it is completed, what are the process it is followed. In short, it will actually audit the change notice. Now coming on to the change management process within Windchill. So Windchill, basically it is having a set of processes and it has got set of workflow present in it. So this particular process involves workflow. The OIR is nothing but object initialization rules, which is actually utilized for the customization. So Windchill can be customized, though it is actually a CM2 compliant closed loop engineering change management. This can be basically customized as per your requirement as well. So all these things are going to be customizable and configured as per your process. As you can see that it has got a workflow. So this particular each artifact, like change request, change notice, the change task implemented, all of them are going to be having a workflow within itself. And these are actually sort of customizable as per the requirement. Like by default you'll not be having electronic signatures for the approvals. You can customize your workflow to incorporate the electronic signature, and so on and so forth. Now, if at all you're having a QMS and you're having a quality management system involved, you do not actually need to go through a problem report or the change request, because it will come directly, the issue has been caught into the audit, it becomes a non-conformance, or it comes as a complaint from the service guy, complaint from the manufacturing side, complaint from the voice of the customer. All these things are going to be taken to actually implement our corrective and preventive actions. So basically it can directly go out to become a change notice. Okay, so Windchill, of course, has got its own QMS system, where you can, as you could see, like, in the initial page itself, I showed you that it is highly, scalable. You can add the functions and features into it. You can add the modules into it. Windchill will be up and running along with that specific module. Similarly, you can add the modules like, audit and non-conformance. You can add the modules like kappa, voice of customer, and so on and so forth. Now, coming on to the bill of material, like if there is any modification that is actually taking place because of change, there will be a downstream BOM that is created within Windchill, like manufacturing BOM will be actually created from the engineering BOM. Make or buy decisions will be created or made taking the engineering BOM. So if there is any modification within the engineering BOM, the corresponding downstream will be notifying that this is an old and outdated data, and this can be actually updated as per the updated new bill of material. We'll see that in the demo in a moment. So engineering change is not just confined to the engineering department. It is going to be a manufacturing, there will be a manufacturing changes that will be taking place. Now, if at all we consider only manufacturing department, there are certain artifacts like standard operating procedures, there will be work instructions, there will be resources. Any modification in that will lead to the change, which has nothing to do with the engineering, because that is something which is a manufacturing prerogative. So in that specific case, the change management will be applying to that specific thing only. So Windchill has got a capacity to configure the change management just for the manufacturing related data, service related data, which is not going to affect the engineering. But engineering being the upstream, obviously the engineering being, the actual data for creation of the manufacturing data, obviously this particular change in the EBOM side will have the impact on embalmment SBOM. Coming on to the demo. So I'll quickly complete the demo. I've actually created we have a video demo because just for the interest of time, what I've done is I've created a video demo and I've kept. So I will actually remove the pointer and quickly run through the demo so that I can curtail the time of actually going into the actual Windchill scenario, and it's going to be time taking. Anyways, I go into the Windchill scenario when I give a complete demo of the of the PLM side. So looking at the scenario where I have logged in as Dave, the engineer, and what I've taken over here is a, a sample where I have already implemented a complete engineering change into one of the brakes of the within the car. A complete car assembly is there within which there is a suspension, a wheel assembly is present, and the brake was having certain issue where it was getting overheated and it had to be fixed. So let me open Windchill. So I'll be going into the product context over here, where there is a synergy car, a top level synergy car, where is a product called as a synergy. And I'm going into the bill of material, the BOM structure of the car assembly. And within that, what I'll do is I will be either expanding and selecting the part. As opposed to this, as you can see, there is a visualization of a car present out over here. You can select the part within the visualization. The structure will be getting expanded and the selection will take place automatically within the hierarchy on the left hand side. Okay, right now though I'm going by selecting the part within the hierarchy, you will see that the corresponding right hand side visualization area will get selected. Okay, I am opening this and I'm going to be opening it by selecting on the view information. You can see the bill of material structure of the car, of the brake assembly present out over here. And even this will be having a bill of material as well as visualization. Now, within this particular scenario, there are two things to be noticed as against the part brake assembly that is present out over here. You can see that, this particular brake assembly present out over here. I will just stop this. I will go back and I would like to point out to this one. So this particular thing, icon that is present as a pyramidal structure, it represents that this particular part has either gone through or going through a change management process. And another important thing to look over here is it mentions as go to the latest. Because what I've done is this has already gone through a change management, and the newer, you can say like newer part is present out over here. It has been changed from version A to B. I have opened the older version just for the explanation purpose as to how it has gone through a change management process. Now let me actually go into the changes tab. The change, I'll not go to any other tab obviously because there are other things like history which gives you the versioning and all those things present. Where used, as I told you, the tab, it will let you know like where and all this particular brake assembly is used. Related object is like where you can go and see what are the objects related to this. Now I will be going into the change tab where you can see all the artifacts and objects of the change. Change related objects are present out over here. Issues and variance is nothing but the problem report that I was talking about. After the problem report, a change request has been created. All of them are associated with this particular product. After the change request, change notice was created and the change implementation actually took place. Let us go into the problem report. Now, once you are actually into problem report by clicking onto the, icon present out over here for the issues and variances, it will be taking you into the problem report. Now you can see the attachments associated with the problem report. In this sense, these particular attachments were created by the person who has actually created a problem report. He has not only created the attachment, he has also created the lightweight representation has been marked. Whatever the lightweight representation that was present has been actually marked and kept over here as an additional representation, which we will be viewing and seeing as to where the issue is. So this will help us or aid us to view and understand where the issue is. So let me go ahead. So I'll be clicking on this particular associated annotation and it will launch the Creo View Express that I was talking about. Once you open the Creo View Express, you can see like it is a scenario just like a CAD software where you can view the data. You can create the markup present out over here using a markup tool. You can also analyze going into the tools. You can create the section of it. All those things can be done within the Creo View Express. Or you can also call it as a Creo View standard. Okay, there are two things like, Creo View MCAD, which is a standard, and another one is Creo View electrical, where you can see the electrical parts. Now, once you are over here, you can see that the person who has created a problem report has marked over here that because of the high speed braking, this particular disk becomes too hot, as a result of which it is wearing out. Okay, now I have viewed it, I will be closing it. And the problem report stands valid. So from the problem report itself, either I can open the associated change request because it is present out over here, or I can create the change request from here itself. So I'll be clicking out over here for the file that is 00021, which is an associated process, which is nothing but the change request. I'll look at its annotation in the sense that it has been reviewed by the person and already suggestion is given and how the suggestion was given. Now the suggestion was given by creating yet another lightweight, using that specific lightweight representation tool, yet another snapshot was created and associated over here in a suggestive manner. A suggestion was given. Okay, and all the affected objects were added into this. Now, after this particular data was added, a suggestion was given, like, as to, like, what way we can actually mitigate this issue and so on and so forth. Now, also when we see affected end items also can be added over here, the affected end item is nothing but your FG, finished good. Now it will vary from process to process or life cycle to life cycle. In the sense, if you look at the car, the affected end item, or rather, I would say that the end item would be a complete car. But when we see the end item or a finished good for the service, it is going to be serviceable part. One of the example of this particular car itself would be a glass for the headlight will not be given. A complete assembly along with the glass, the bulb, the structure along with it, the gasket enclosing it, all of them will form one single kit. So the kit will be given as the end item. So we can consider the brake assembly as the end item present out over here. Similarly, there could be multiple end items present. So affected end items is also present out over here. Now we'll be going into the related process, associated process object, which is going to be nothing but the change notice. Here you can see, like, the process present out over here. You can go into the routing process where you can actually see the complete workflow process. Now this is something which only the administrators or the admin level guy can see. Maybe like a Windchill administrator or the organization administrator can view this particular flow. Not everybody, not the end person will be able to see this particular process. This process can be modified. One of the example is, like, wherever you are seeing human face, this simply means that a human intervention is required. Wherever you're seeing something called as the icon where you have a decision, it is going to be a conditional ones where the decision is there. So it is going to be an automated process where this happens, this is going to happen, this happens, this is going to happen. There are other things like robots present out over here, which will actually be keyed in certain function and kept, and they will be acting accordingly. So this is a complete process present, a workflow process for the change notice that you're witnessing right now. Okay, I'll be closing this particular thing. Coming back into the change implementation, where I will be implementing the change, where while time of implementation of a change, I will be giving a change task, assigning a change task to somebody who has actually made the change. Now, since the change has been made, there is something called as resulting object vis-a-vis affected object. Okay, under the change task. You can even do the structure comparison, apple to apple information comparisons, where what change that has taken place in the A9 vis-a-vis B1. So it has changed from A9 to B1. It has changed from the released state. It has actually come back to the invert state. So we will be opening and seeing it in the Creo view as to what modification was done. Now, the modification was done wherein the holes were added to increase the surface area. And then once that is done, a pattern of holes are created, saved, and closed. And then coming back to the home page, there is a change notice task which is present in my plate as a change notice to be completed by me. Before I complete this particular task of change notice, I have to see what are the other impacts that has taken place. This has already been released for manufacturing. So I will be going into the part and viewing by going into the manufacturing part structure browser. This is a manufacturing part structure browser. I'll open and see as to what change needs to be created as per the new EBOM into this particular MBOM. So I will be going into the part, and as you go into the sub-assembly of the brake assembly, as I see this, you can notice that there is a clock sign instead of having a right check mark. And also the assembly, preceding assemblies are also having a clock sign because of this particular part. What I'm going to do is I will be going ahead and I'm going to bring it onto the equivalent level by right clicking it, and I will be giving it the command as update to the current upstream equivalent object. Once I do that and click OK, you will see that even this particular part has got holes in it right now. It has updated in the visualization area. I'm going to check in. Once I check in, I'll say apply to all, and I'm going to be completing my change notice task. And now I'm going to be logging in as the reviewer or the auditor for the change notice task. So before completing or review of the change notice task, what I will be doing is I will be completing this, but I will be giving certain effectivity date onto this. I'll close this, I'll accept it, and I'm going to go to the latest design present out over here. As you can see, like it is A9 that we have been seeing so far. I'll click on go to the latest. It goes to B1, but it is actually in work state. I'm going to be giving, I'll be going into its change, the change tab. I will be going into its change notice, and I'm going to be giving it and yeah, I'll select the parts actually. Whatever the part is a resulting part now vis-a-vis the affected parts. I'm going to be changing its state, giving certain dates. I'll be giving it a date, and then I'm going to be changing its state. Going into the actions, I will be changing the state from the in work state. I will be changing it to the released state so that all of them are actually released along with the top level car assembly. Now I will be closing this particular task, and then there will be an audit on this. I'm going to be actually opening the part, and then I will be doing a structure to structure comparison where you can see both the structures look, there is a variation between the A1 or sorry A9 as compared to the B1. So we can clearly see what are the modification. So we can do the apple to apple comparison. Once I'm convinced, I will be going ahead and I will be closing the change audit task as well. So this was about a complete change management process. Okay, so considering this particular change management, there are few examples that we have. Like one of them is a Valiant, which is the overseas group, and if at all we consider the Indian industry, which is Kirloskar Oil Engines, which has successfully not only successfully implemented the change management, but also, reap the gains of this particular change management process, a complete engineering change management process. So, if at all we consider specifically Kirloskar Coil Engine, so it is they have got 10% reduction in the last stage engineering changes, which is actually a big issue with the engineering related changes. 73% reduction in the product related changes, 25% drop in the product code and new parts. So what exactly engineering, how it is going to be beneficial to you? It is going to be giving you a process which will expedite, make your change management process more faster. It will make it, more accurate, and it will be having a better response to the internal and the external market. It is going to be giving you a proper result which will actually release the pressure out. It is going to be having a proper automated processes. It will increase the change management efficiency, as a result of which it will reduce the scrap and rework and increase the productivity. So, yeah, so that was about the engineering change management. So if there is any questions, please feel free to ask. Mayur, do you see any questions in the chat?
No, not yet. To all the attendees, if you have any questions, feel free to ask. You can unmute yourself, or if you want, you can type your questions in the chat box and we'll answer it right away. All right, doesn't seem to have any questions at this moment, but we are always just a call away, or you can always write to us. You can reach out to our team to know more about how Windchill can help you in proper engineering change management and improving your overall product development process. Thank you for joining us today for this webinar. I believe we could provide you with the insights into how a well-implemented engineering change management at an enterprise level can drive an organization's efficiency, how it can help you reduce errors and ensure that the compliance is properly followed as per the industry standards. So that was the whole motive of organizing this today's webinar. Again, many thanks for all the participants in attending today's session. Let's stay in touch and look forward to again seeing you in the next webinar. We will organize the next webinar after 2 weeks from now, and we will provide you with all the necessary details before joining the webinar. So again, thank you very much. Look forward to meeting you again. Bye.
Thanks all. Thanks for your time.